Hey everybody, we're going to go ahead and get started with our 1 p.m. session, which is a workshop called Scales of Real Time by Farzin Lofti-Jam, who's here from Cornell. Farzin is an architect whose work explores the politics of technology and cities. He's an assistant professor in architecture at Cornell, where he directs the RealTime Urbanism Lab. The lab uses and invents new spatial media and technologies to visualize and simulate how algorithms, models, and notions of real time govern urban life. He is also director of Farzin, an interdisciplinary design studio working across architecture, urbanism, computation, and media. From modeling the control matrices of smart cities to spatializing the cultural logics of social media, his individual and collaborative projects are research-based and multi-mediatic. I get that? So Farzin's going to be giving us a great workshop today. I really encourage everybody, if you have a laptop, to pull it out, because we'll be using those. And I'm personally so grateful to Farzin for joining us. He called me a couple weeks ago after hearing about the conference, and we had a really wonderful, 2-hour-long chat. And at the end, I was like, why don't you just come and give us a workshop? And I'm so thrilled and excited. So thank you for joining us. And I guess let's go ahead and get started.
Hi everybody, how you doing? Thank you so much, Annie, for having me, and thank you, Joe and Tom, for organizing this. It's been such a wonderful conference and event so far, and topics very close to my heart, so I'm very excited to kind of try to add a little bit to today's discussions. So today I'm going to be talking about scales of real time, and just as a kind of intervention into our conversation today, try to unpack something around this term, real time. So this little Zoom thing is going to come back in a second. And this is going to be kind of a little bit participatory, so I appreciate your patience, and it's going to be a real-time demo. And if you know anything about live demos, you probably know that everything always blows up in your face. So we're going to try to literally see if we can kind of kill my computer by getting it to do too much in real time. So if that happens, that was my intention, and it's a total success. And I'll wait for your claps when that occurs. And so the conference today is about RealTimeNature, and it's really, as I understand it from the panels this morning and the amazing talks, we're thinking about how the natural world is increasingly subject to what I think about as the 3 M's of contemporary life. And I want to just do something where I'm going to take the conference title and flip it around for a second, and I want to try to get at something called the nature of real time. And what do we mean by this term? What is its aesthetics? What is its history? What are the technical systems? What is its spatial and political histories? So I think contemporary life is getting more and more subjected to the 3 M's and the 1 C. So we're subjected to more forms of real-time monitoring that we saw a lot of this morning, real-time modeling, real-time management, and ultimately real-time forms of control. And I want to kind of try to tease out what this means. And so this workshop is structured as a series of real-time episodes where I will reverse this conference title to try to understand something about this. And really, I'm kind of arguing that real-time, as we understand it, is a kind of a combination of communication, computation, and media. And I want to try to play with forms of real-time communication, computation, and immersive media. And I want to do that to, I kind of I'm asking a very simple question, and maybe, which is just, what is real about real time, and how timely is it? And I'm currently working on a book project that's the sort of prehistory of real time, where I'm trying to map out things like this. So this is a very typical moment where you might be, right now what I'm doing, and maybe what some of you are doing right now in the audience, where you're sitting in front of your computer, you click a button, it is routed through your peripheral systems, your USB, into your computer. It goes through your, it activates your CPU, your RAM, your GPU, and ultimately the sort of input from your mouse changes the pixels on your screen. And that starts to happen at different speeds, and that shift in the pixels on your screen is registered by the visual cortex and the frontal cortex of your brain. That information is processed, a signal is sent to your finger, and you move your mouse again. And so this is a kind of a classic real-time loop where we're caught between your finger is connected to your GPU, that's connected to your screen, into your eyeballs at about 180 milliseconds right now. And so I'm starting to produce drawings like this, and I'm thinking about how real-time is a kind of a temporary architecture, an ephemeral architecture that connects fingers to eyeballs via brains at vast and intimate scales, and that it has a very sort of specific latency and a very specific physical footprint. And so here we can see a kind of an ephemeral architecture, right? For about 110 milliseconds, we've created a temporary architecture. And obviously real-time is nested in some way. So as I'm clicking that, as I'm clicking my mouse button and my screen is being updated, in this room right now, I'm being seen by all of you. You're also seeing this screen. We're being captured live on these cameras. And so real-time computation also meets real-time broadcasting. And so real-time is kind of nested within histories of televisual presence, where the capturing and the production of live media events meets networked live computational events. And so these two kind of histories between televisual real-time and computational real-time is something I'm trying to explore. And I think it's something that actually Peter Gallison really got at this morning, right? Like what is the kind of media impact of real-time images? And in my work, I'm trying to kind of understand if the front end of a real-time image is some of the types of technical images we saw this morning and some of the ones that I'm going to show today. The back end of it is these vast, giant infrastructures that transcontinental servers that kind of capture us and connect us through things. So the talk is going to be kind of like, it's going to be seamlessly, or like the workshop. I'm going to jump between my PowerPoint and a few things I've made for you, and I'm going to sort of show you, it's going to go from smooth broadcasting to something messy a little bit. But let's take a break for 1 second, and let's go to here. So if you have the internet available to you, github.com/realtimeurbanismlab/nature of realtime is where the repository for today's workshop is. And you don't have to click this right now. It's totally okay if you just watch it on the screen. But if you want to see some of the things that I've created, and if you want to download and clone this package, you can have it later for yourself. But I've also hosted a live version of the final output here, which is here. Okay, what's real time? Does anybody know what real time is? Anyone? This is real time. So input got processed at the same, input and output was processed at speeds imperceptible to human cognition. But real time is also this. I just pressed that button and it just moved here. And I just pressed that button and now I'm just captivated. I don't know, maybe I like my own work too much. But this type of interactive loop, let's say, is something that I'm very interested in. How visual real-time, how real-time computational images entrap us in some way. And something that I was very curious about from the panel this morning that I think was going to get teased at is that there's something seductive about real-time media. It has a kind of computational authority. It has a sort of a glee of responsiveness that captures and traps. And whether this is interactive concept art, let's say, but looking at models, and so many times this morning we heard about the slider, right? That these sort of buttons that allow you to explore, so that exploration of data and responsiveness and the desire to create more data in real time is something about the value of liveness that I also think computational media networked in this way produces. All right, so we're going to jump between that screen and this screen. And so these loops that we kind of get caught in also just captivate us. This is also a kind of a real time, right? And we can stare at this at a gradient being animated very slowly and hypnotically, and maybe that's too fast, or maybe that's too slow, or maybe that's just right. Like, it's just very slowly moving, and we have this loop that's happening within the kind of computational subroutine in real time, and we start to give visual form to computational systems. And so this kind of the loop that I think many of us are thinking about is a primary sort of aesthetic condition of our lives under different forms of real-time computation and televisual experience. I quite like the radial, so that we could probably sit there for a little while. That one feels good. Does that feel good? Yeah? Slower? Yeah? That one? We can do like different colors, but they're not as good. Like, we can go warm. Oh, ooh. That one looks very alarming, so something's definitely happening. Sorry, trigger warnings. We're going, oh, that one's very nice. Okay. So let's go to the radial. I like that one. This one's actually quite weird. I was trying to make a sphere. It didn't happen. But that one's pretty good, right? So this one might remind you of the throbber that you have on an old MacBook, right? And that moment where your computer is telling you in real time that it's going to take a little bit longer than real time. But that display of a type of signal that holds you is enough to manage your attention until your anxiety that's building up gets released. So I just want to hold the loop in your head, and maybe that's one of my first kind of real-time concepts. But my first real, pardon the pun, encounter with real-time happened in 2017, when I think real-time started to return. And in 2017, Epic Games, the creators of the wildly popular game Fortnite, began a major push into new markets with their Unreal Engine technology. Originally a gaming engine, Unreal's rapid evolution was driven by the unexpected financial success of the game Fortnite, which led Epic to make Unreal Engine free for public use. So this opened the door for Epic to push their engine into a wide range of industries, from film and motion graphics to architecture and urbanism. And by 2019, Epic Games formalized this shift with the launch of their $100 million Epic Mega Grants program, which significantly broadened the engine's application beyond gaming. This marked a turning point for digital culture and signaled the rise of real-time rendering, which you're sort of seeing here, that Epic was marketing their tool, real-time sort of 3D visualization, as a way to architects and to urban planners, as a way to supersede the endlessly spiraling V-Ray bucket. Has anyone sort of spent nights staring at that V-Ray bucket? Yeah, I think I've sort of spent my entire life looking at that. And so this was kind of the first thing that Epic was really thinking about real-time visualization in this way. But, you know, going back to this kind of article that was written by someone at Epic to kind of usher in this real-time imaginary's future, this also marked a turning point where different ideas around urban management and virtual production pipelines and 3D avatars that were all synced in live motion would kind of come under new forms of real-time. And you know, I kind of think this, the appeal of real-time technology, though, as many of us know, isn't solely a modern phenomena. And in a book project I'm working on, I'm trying to sort of trace that prehistory of this concept through longer histories of communication and computation that come out of the imperial machinations of territorial management. And so this historical lineage continues to shape our urban environments and our natural environments today. And the adoption of the Unreal Engine in architecture and urbanism has initiated what I'm terming real-time urbanism, a new era in which products like digital twins, immersive simulations, high-res visualizations, many of the examples we saw this morning, become essential tools for managing natural and urban environments. And so real-time is a conceptual, technical, social substrate for contemporary digital environments. and it operates across wide sort of applications from military, entertainment to urban. And so it's a kind of collapsing of all these different concepts. And these technologies are fueling new forms of instantaneous surveillance and dynamic data analytics, and their reach extends into sectors like the military and realtor. And so this episode, the first episode, I'm trying to kind of set the stage for our deeper investigation into the nature of real-time, and exploring how these tools and systems reshape not just digital media, but the politics of space and power. And so if the throbber that we were looking at before, the spinning sort of, the waiting that your computer's about to get real, but you have to wait in real time for it to become real time again, creates a kind of an aesthetic experience of anticipation. And to kind of try to tease that out a little bit, I want to look at these three sort of semi-recent forms of media in which we see kind of how humanity is rendered through contemporary real-time computational images. So a human is a particle in a linear flow. A human is a skinned mesh in a complex flock. A human is one part of the stroke thickness in a network of lines. So goes the depiction of individual identity in three recent-ish real-time computer simulations of urban movement: a New York Times article, a PlayStation game, and a new software-as-a-service urban planning tool. What do these examples from news media, interactive gaming, and city management reveal about what it means to be a human in the contemporary city? How do they shape the urban imaginary, and what compels so many computer operators to obsessively watch how humans move in real time? Each of these simulations shows the movement of bodies, but in different ways and to different degrees of real time. And I'm interested in understanding how this urge to track, visualize, and anticipate the movement of urban environments and populations in real time is deployed as a technique by different actors to shape subjects and territories and environments. And so the first real-time media is this one. It's a data-driven news article published by the New York Times titled "How the Virus Got Out." And it chronicles the spread of the coronavirus from the Wuhan region in China to the far reaches of the planet. The webpage consists of live computer simulations of hundreds of millions of people's movements visualized as smooth flows of dot-swatch PNG particles gleaned from multiple cell phone data sources. The simulation is coded in the JavaScript programming language and consists of over 60,000 lines of code, and scrolling the page triggers different dynamic visualizations. A good fraction of the 60,000 lines of computer code runs different subroutines that reconstruct pre-processed location and geospatial data in different historical simulations of human movement. And here the degree of real-time is really in that scroll-activated near real-time responsiveness. As you scroll the website, different forms of real-time media pop up. And so I asked myself, why is it so important for these data visualization routines to run as live computer programs within the browsers that combine geospatial data with narrative content? Why spend close to 10,000 lives of coding labor optimizing the site for runtime performance rather than pre-processing the animation frames and encoding them as video files? Clearly, there's a certain value that is placed on these information visualizations appearing live, that running in real time, and on the authority that communicating with computer models produces. And there's also that build-up of anxious anticipation in the user's cognition with every scroll of the page that is pleasurably rewarded with the release of dopamines when a new visualization commences. This one's really fun. The second simulation can be seen in the trailer for Humanity, a PlayStation 5 game that was created by THA and Enhance, and it's set to hypnotic beats scored by the legendary Japanese musician Cornelius. And this 1-minute teaser is a dizzying array of tracking and dolly shots capturing scenes of mayhem featuring massive crowds of computer-generated humans pressing, elbowing, and pushing past and into each other with careless and oftentimes violent abandonment in a series of abstract environments. Although this specific media is an MP4 video file, I assume it is showing documentation from in-game play developed using the Unity gaming engine, with the behavior of the digitally skinned humans being informed by agent-based modeling techniques. These humans run at 60 frames per second real time based on a series of local rules which makes each play slightly different. The third simulation is available in Replica, a next-generation urban planning tool developed by a similarly named startup that was spun out of Cyborg Labs, which was previously owned by Google parent Alphabet. The specific of this simulation have to be pieced together from friendly promotional videos shown here, helpful blog posts, government procurement forms, and a confidential methodology document with protected trade secrets that was accidentally made public. Replica produces simulations of synthetic populations moving around different US cities, virtual humans that go about their daily lives ambling from home to work to lunch to shopping or other, using different modes of transport. The company uses machine learning methods to translate what they term near real-time location and behavior data tracked from real humans that represent a small percentage of the population, and then they kind of cast this into abstract persona models that allow for different decision-making matrices. These persona models are then matched with virtual humans that are statistically correct representation of an entire city's population based on census data. And so the aggregate results of these synthetic populations are then presented to users in a no-nonsense mapping interface. And so these three simulations are the results of longer histories concerned with the development of algorithms, infrastructures, and theories to track, model, and predict the behavior of individual subjects and populations. They're also connected by the specific simulation models they implement. The first, the New York Times article, translates statistical representations of human behavior from recorded events and cell phone data into a computer model. The second, humanity, is the activation of a theory of autonomous human decision-making through computation. And in Replica, which I think is kind of this new paradigm, these two historically distinct techniques for modeling human behavior and movement have converged into a new urban platform. So recorded data about actual human movement is being used to drive a theoretical model of how humans make decisions. Okay. You got that? So there's a few preambles. I want to give you like one last preamble, and then we're going to do something fun. And so I want to take a moment to kind of understand the longer history of some of these different techniques. And if you start to trace the term real-time, you inevitably end up looking at this project, the semi-automatic ground environment, a famous Cold War military program within the history of cybernetics, and the production of what we're seeing here, which is a real-time image of the North American airspace, where a vast series of infrastructures were built to produce a live representation of aircraft movement in North America. So behind this real-time image where you're seeing the trajectories of live aircraft movement and predictions of possible future movement is the reason why we have the real-time digital computer that we're all using. So I think many people know this history, but behind that real-time computational image that I just showed in the previous slide is this vast physical infrastructure where a network of radar stations, massive input computer systems at the scale of buildings, and semi-automated responses are all brought together to create a real-time monitoring of the entire North American airspace. And so these types of concepts like flexibility, concepts like responsiveness, concepts like liveness are all kind of organized by these military modular forms of computation that emerge for this reason. Okay, cool? Great. So let's do something fun. Let's go horizontal. So one thing real-time does really well is probably something around simultaneity. This image is pretty good. You're seeing me up here. You're seeing me there. I could turn myself on here. Seeing two of me at the same time is pretty captivating. Are you into that? Is anyone else into this? Yeah? So my second concept around real-time is this. That's what I look like, wow. is simultaneity. So the aesthetics of simultaneity, or what sometimes is called televisual presence, or this kind of broadcasting of a single event from multiple vantage points that you get to look at in real time. And I thought with the first panel this morning, when we were looking at the 2x2 grid of the animals all moving at the same time, something about the same event rendered from multiple perspectives in real time is just utterly captivating. Like, we don't have to kid ourselves. This is a very banal kind of event that I'm documenting right now, myself moving. But just by placing it within a grid and showing it to you simultaneously, it creates a kind of captivating experience. So if you have two webcams on your laptop like I do, and you go to the website, you can do this to yourself. I've danced in front of this. Like, I won't lie to you, I'm not a huge narcissist, but something about this kind of watching yourself and the surveillance of self, the computational monitoring and representation of yourself is incredibly sort of captivating, but it's also producing a type of neurotic urban subject that is seduced by wanting to take banal aspects of their own life and monitor that. Okay. And then in that semi-automatic ground environment example that I was showing this one, what's important, I guess, to note here is this giant amount of infrastructure that I think we're all familiar with, and its purpose was quite literally to produce this particular architecture and this particular image. This image was monitoring live how actual aircrafts were moving through the North American airspace, but at the same time, it was producing trajectory predictions of future aircraft movement. So in order to produce a live image, and in order to produce a trajectory of possible future movement, records of the past had to also be kept. So real-time's focus on the now is also a way, the same infrastructures that produce the live image produce recordings of historical events that fuel predictions of future. So between now and the liveness of real time is a series of ways to think through records of historical past that drive future permutations. So I want to kind of just emphasize the relationship between the now, the past, and possible futures. So even though we have a lot of real-time monitoring, it also creates all sorts of real-time futures. Okay, should we have a look at something like that? This one's pretty fun. This might be like my best one. So some of these ones aren't good, so let's have a look. So the final little aesthetic experience that I want to give you around real time is delay. A recursive delay, an echo, a kind of present and future. So in this little sketch, we can kind of see that in the top left is real time, and everything from here sort of deviates out. I have danced in front of this one for a while last night. Let's have a look. So let's try increasing the delay. This gets pretty funny. So that's real time. That's minus 1.4 seconds real time. That's minus 2.8 seconds real time. And we killed my computer. Congratulations, we did it. That was the first crash. Okay, claps. But I guess these different types of real-time aesthetics also get layered on top of each other. So in the same way in that first example, I showed you that a human was caught in a loop with their computer, but at the same time that they're caught in a loop with their computer, they're also being broadcast through televisual systems. And so we have nested ideas of real-time, but we also have layered kind of real-time aesthetics on top of each other. And so, that's so funny. So we can kind of take that simple real-time echo that we have, we could try to randomize it, so it gets a little bit more complex. So now real-time is there. We can also introduce a slight kind of delayed tinting. So by combining delays, loops, concepts of simultaneity, interactive responsive media, we start to get about 5 different concepts around real-time producing this image that crashes my computer once again. Thank you. So have fun with that. It looks like it's only going to work on a 2x2 on mine right now. So loops, simultaneity, delays, and I guess kind of a layering of aesthetic experiences. Okay. And then maybe just to kind of drive home that point, the last thing I want to kind of talk about real time is this kind of concept of fidelity and change over time. And a lot of the sensors that are monitoring environments now are video cameras, right? And so actually the world has been kind of fully infiltrated with different forms of video surveillance, and then taking the video, and I think Peter was showing this so well this morning, taking the video feed from a kind of linear perspective documentary history and placing it into a measurable, quantifiable form of data starts to create forms of analysis like this. So what we're doing in this little sketch is we're taking the current frame, and then we're taking 12 previous frames, and we're just doing a delta operation to see what's changed. So this allows us to track changes between pixels, which is the sort of underlying technique that drives many forms of machine learning behavior monitoring, where surveillance cameras in urban environments and retail spaces in all sorts of different applications are reading the delta pixel to see if something has changed. And then based on that change, that array of difference is subjected to different forms of machine learning to try to extract behavioral concepts from it. And so these two things are tied together, where there's a temporal fidelity and there's a resolution. There's also a visual fidelity. So this one, I kind of really like it when it gets down to here. Let's get down. Cool, that seems good. I feel like that right now. I think I'm like 8x6 pixels right now. And if I'm really honest, there's only about 1 frame of historic past within my cognitive capacity right now. So that's kind of just to kind of, loops, simultaneity, delays, layering, fidelity to temporal, and spatial representation. Okay. And so just to kind of wrap up with like the final little concept, I want to introduce an idea around the simulated human other. And so 7 academics in California authored a paper on the emotional state of a woman in Iraq. Her name is Amani, and she wears a headscarf and a long skirt. She stands alert, arms back in front of an interior wall. Behind her are framed artworks. A photograph of the Al-Askari Mosque, a painting of a camel, a snow-covered landscape, and a portrait of an Ayatollah. To her right, her brother Mohammed sits in a wooden chair. He is not interactive but identified as her chaperone. Amani is a virtual real-time human. She was created by the Natural Language Dialogue Group in 2009 at the Institute for Creative Technologies for, quote, technical questioning competence training. By 2011, she was onto her second system architecture and had been used in over 68 simulation training experiments by cadets at the United States Military Academy at West Point. In these sessions, cadets were instructed to question Amani to gather intelligence about a sniper who had wounded a soldier. Amani was described as, quote, female, single, Islam, Shiite, end quote, with duty positions including, quote, housekeeper and guardian of siblings. Cadets were advised to gain her trust. Begin the questioning with greeting Amani. Gaining her trust and comfort is key to getting any answers from her, and be prepared to offer protection to her family if she needed it. They were also cautioned if Amani becomes too hostile or indicates that she no longer has time, end the interview before too much ill will is generated. Amani, along with other virtual Iraqis, is what's called a virtual human. The term virtual human or autonomous agents, avatars, digital doubles, encompass a broad range of interpretations. At its core, it refers to the digital modeling of human form, behavior, and cognition. And so, has anyone kind of created a memoji? Do you have an Apple iPhone? Yeah? Have you made a memoji of yourself? So if you've ever have you started to see these virtual avatars creeping into different parts of your life? Just the longer history of this kind of comes back to episodes like this, where in order to facilitate different forms of tactical training for military operations, simulated human others are being produced in real time. So I want to kind of just create a version of that to sort of show how this technology has gone from civilian, from military context into civilian applications. So this is a metahuman in the Unreal Gaming Engine. If you've used the Unreal Gaming Engine, this is one of the default metahumans that you can download. And you can actually get an app for your iPhone called Live Face Link that will load in a second on my computer. One sec. So those infrastructures of tracking, those forms of visual analysis of video images, different theories of human modeling and cognition have all kind of come together in this moment where for YouTube influencers, for military operators, for consumers of digital culture, you can create a live avatar, one that is a default from Unreal Engine, that you can start to then drive in real time. Let's get this person out of the way. And this is my big reveal. We're obviously standing in front of Harvard. And if we kind of start to move between this image, maybe we can go here where we're capturing that. So we're starting to kind of like layer up the live capturing here on my phone. So let me show you what that looks like. Is it this one? Yep. Can you see that? No, it's not that one. Let me change that. You know what it is? The issue is I have it open. Okay, we're gonna have to do this. Can you see this? Can you see that? I can't see if you can see it. A little bit? Yeah? Okay. So we have, I think everyone's seeing these mesh models that track faces with different landmarks. Behind this is a true depth camera technology in your Apple iPhone. So this is basically the memoji technology sort of shifted over. The hardware that we have here, it's projecting something like 30 dots onto my face right now. It's capturing those projections, the depth map. And then this is now for, kind of popular cultural entertainment, let's say. So this histories of real-time responsiveness as they start to enter into civilian applications, as they start to become, this took 20 minutes to set up, right? It's like so accessible. And so the idea is to now use these real-time socio-technical systems to mediate all these different forms of social life that we've all been creating together. So now that we did all that, so I kind of set up liveness, I've set up delay, I've set up loops, I've set up tracking, and I've kind of shown that the targets and objects of real-time are not just nature, but generally human beings and populations for forms of management and control. Let's do something fun together in about 5 minutes. Okay? Who has a laptop? Who knows how to use Zoom? Join my Zoom room. Let me just kill my camera here. Please join the Zoom room. You can use the Oh yeah, Hamid. Good, fast. Oh my God, Matt, fast, impressive. So we're live streaming to Vimeo right now, and I think we have like a small delay. And so what I want to try to do is see if we can map out the aesthetics of real time in real time. So just disclaimer, by joining the Zoom room, you consent to being broadcast. So if you don't mind, if you feel comfortable, please turn on your cameras if you're in the Zoom room. Hey. Hey. Hey, hey, hey. I should turn on mine. That's only fair. Let's do this. Okay. I'm going to give you something to download if you're in the Zoom room. Okay, so please download that image and set it as your background if you can. So this is something called OBS, Open Broadcasting, and it lets you capture all sorts of different images. We can do a live chroma key. So I'm just going to chroma key out all your colors. So there you are, you're all in there live with me. Let's get Amani back. Sorry, not Amani, the metahuman. Okay, should we get my PowerPoint slides? Okay. That doesn't seem to be so good. Let's not do that. Okay. So when you hear my voice, get ready to clap your hands. Ready? So when I say clap, clap your hands. Clap. Okay, that's how real we are. Thank you. That's it. Any questions about anything? So if you want to recreate any of these little tests, you can go download this repository here. The one thing that I didn't show you is that the geography of that experience we just had, and this is something I pre-cooked when I was in Ithaca at Cornell just earlier. This is the network route of going from my house to the Zoom servers. So the experience we just had has this geography where my packet of information is tracking from Ithaca through Trumansburg via New Jersey all the way to Zoom servers in California. and we can follow that path at the speed of a very fast car. This is how quickly a 747 plane will do it, and this is the speed of real-time. Thank you. That's the geographies and the aesthetics of real-time.